Hi students, welcome back to the virtual platform of Digital Logic. So we have been discussing the different types of functional units of a computer. So what we have already discussed, the first functional unit of the computer is input unit. So input unit is responsible for taking input from the external environment. So who are the external environment for the computer? We are the external environment for the computer. So we will give the input to the input interface, then input interface will convert the input. Why the input interface will convert that input? Because we are giving the input to the computer in high level language. So that's why input interface will convert the high level language input into the machine readable form, that is into binary form. After converting the high level language instruction into the binary form, then the input interface will give that binary coded instruction to the computer. So that is the work of input interface. Next we have discussed the output unit. What is the responsibility of output unit? That is, in case of output unit, when the computer is processing on some data and instruction, then the computer will produce an information. So there are some output interface that will take those information, that is in actually binary code. So that will take the information from the computer. Then the output interface will convert the information into the human readable form. Because we are acquainted with the high level language, but our computer is producing the information in case of binary code. So that's why there should some output interface that will convert the binary coded information into human readable form, and the output interface will give that human readable form, that means the human readable information to the external environment, that are we. Next we have the third functional unit, that is the storage unit. So storage unit is responsible for storing the data and information. So if we are providing the data 2 plus 3, so there 2 and 3 are the data and plus is the instruction. So the first thing that the storage unit will hold, that is data and instruction that will give by the user through the input interface. Next, the intermediary result. So to get the final output, what are the intermediate result that we need to store for a longer time? So that is the intermediate result, that is also held by the storage unit. And the final thing that the storage unit is going to hold, that is your final result. So three things can be held by the storage unit. The first one is data and instruction. The second one is the intermediate result, and the third one is final result. So we have left with the storage unit. We have two types of storage unit, that is the primary storage and the secondary storage. If you remember the von Neumann architecture, so there we have already discussed, so what is the storage unit and what is the central processing unit. So in case of storage unit, we have two types of storage. The first one is primary storage and the second one is secondary storage. So in that figure, the secondary storage is on the top and the primary storage is at the down. That means the primary storage can be only accessed by the central processing unit. So whatever the data and instruction that is on the secondary storage, if we want to process that data and instruction, then we need to send them into the primary storage, because the CPU can't access the secondary storage directly. The CPU can access secondary storage indirectly through the primary storage. So we need to send the data and instruction, those are stored in the secondary storage, to the primary storage. Then from the primary storage, the CPU is going to get that data and instruction. Then the CPU will process those data and instruction and will produce some information. Then if we want those information, then the CPU will send those information into your primary storage. Then if we want to store those information permanently for a longer period of time, then we need to transfer those instructions from the primary storage to the secondary storage. So what is that primary storage, what is that secondary storage, and other two units have left, that is arithmetic logic unit, control unit, central processing unit. So let's see what are those. So let's have a look into the primary storage. So it is used to hold running program instruction. So what is running program instruction? That means we have some data and instruction within our computer. If we want to hold them for a longer time, then we need to transfer them into the secondary storage. So like we have our pen drive and we have some movies on that pen drive. So we cannot watch that movie from the pen drive without having a computer. So when we want to watch that movie, we should insert the pen drive into our computer and we should open that movie. That means when we open that movie, that is the running program. So we have lots of program, or we have lots of instruction with our computer. So whenever we execute some instruction, so that time, that means that instruction is going to executed by the central processing unit. So who is responsible for holding those running program instruction? That is primary storage. So that what I have already told you, that whenever we want some execution, we need those data and instruction to be transferred from the secondary storage to the primary storage. Then only the CPU can access the primary storage, because the CPU have the direct access on the primary storage and the CPU does not access the secondary storage directly. So that's why we need to transfer them. So that what actually it's saying, the running program instructions can only held by the primary storage. And the next point says, it is used to hold data, intermediate results and results of ongoing processing of a job. So if we are executing a job, then what are the ongoing processing data, what are the ongoing processing intermediate results, that are also held by the primary storage. So when we will go for further classes, there we will know what is job, what is the job scheduling, what are the processing time, what is data transfer rate. So there you will better understand this, but now you just remember whatever the ongoing processing jobs or whatever the running program instruction that is executed by the central processing unit, that should be in the primary storage. Until and unless the data and instruction is inside the primary storage, we cannot execute them. If we want to execute something, that must be in the primary storage. And the third point says, it has the first in operation. It is first in operation. Why it is first in operation? Because who is responsible for operating something? That is central processing unit. CPU is responsible for operating something. So there we have already told things, that is control unit and arithmetic logic unit. So the central processing unit has the direct access on the primary storage, and the central processing unit has no direct access to the secondary storage. So who will be very first? Obvious, the primary storage. If I will directly access you, then you will better understand me. If I will teach you through this video lecture, then it will be quite difficult for you. The classroom teaching is very much familiar with you, but this video lecture is quite difficult. So that's like that. If the CPU has a direct access in the primary storage, that means the primary storage, obvious, it will be operate in a fast manner. If the CPU has no access or no direct access to the secondary storage, obvious, the secondary storage will be very slow. So that's what it's saying. And the fourth one says, it has small capacity. So what actually that, when we are going for buying a smartphone, we are preferring 6 GB of internal memory and 64 GB of external memory. So that is what? 6 GB of internal memory is the primary storage. We can purchase a bigger capacity of secondary memory with a lower cost. But when we prefer for primary storage, that will be very costly. For a small capacity or for a small storage, we have to pay more cost. So by comparing the primary storage and the secondary storage, in case of primary storage, we can pay more for a small capacity of storage, but in case of secondary storage, we are paying less for the larger volume of storage capacity. So what actually that says? Next characteristics of primary storage is expensive. What I have already told you, that for the small capacity we are paying more, that means it is much more expensive than the secondary storage. And the last one, it is volatile. So what is that volatile means? That means it loses data on power failure. So what is that? Take an example, suppose you are working on some document in the Microsoft Word. If you have not saved that document and the power supply has been up, then what actually happen? After your computer will restart, that document will be lost. Why? Because we are working on the Microsoft Word, that will be in the primary storage, while already I have told that ongoing processing jobs or running program executions, all those are in the primary storage. So when we are working on the Word document, that is actually we are going through the processing jobs. So when the power supply off, whatever the data or the instruction in the primary storage, that will be lost. But consider whatever in our secondary storage, that means whatever in our hard disk, in the pen drive, in the CD, when the power will be up, the data and the instruction or the information will retain forever. So in the primary storage concept, when the power supply failure or when the power supply is off, the data and instruction is going to last forever. So that is volatile in nature. If something or if the secondary storage retains the data and instruction even if the power supply is off, that is non-volatile. You just remember these two words, volatile and non-volatile. Volatile means it will lose the data and instruction if the power supply is off. Non-volatile means it will retain. That means the data will never lost. It will retain the data and instruction if the power supply is off. So these are the characteristics of the primary storage. Let's have a look into the secondary storage. So in the secondary storage, we use the secondary storage to hold stored program instructions. By comparing the secondary storage with the primary storage, in case of primary storage is used to hold the running program instruction, but the secondary storage is used to hold the stored program instruction. That whatever the program instruction we need to keep in our memory forever, that we need to store in the secondary storage. And the second characteristic says it used to hold data and information for stored jobs. There what we have seen, that is for the processing jobs. For the currently processing jobs, we need to hold the data and information in the primary storage. But in case of secondary storage, we need to hold the data and information for the stored jobs. Whatever the job that are processed or that is going to process, those data and information will be stored in the secondary storage. And the third characteristic says it is slower than primary storage. I have already discussed that the CPU has the direct access on the primary storage, so that's why it is fast. The CPU does not have any direct access to the secondary storage, that's why it is slow. So by comparing the primary storage to the secondary storage, obvious the secondary storage will be slower than the primary storage. And the next characteristic says it is large capacity and it is less cheaper than the primary storage. Already I have discussed, for the large capacity or for the large volume of storage space, we are paying less. But in case of primary storage, for a smaller capacity, we are paying more. So it is less cheaper than the primary storage. And the last one, it says it retains the data even without power. That means it is non-volatile in nature. So you should differentiate the primary storage and the secondary storage by looking at these characteristics. The primary storage is known as the main memory of the computer. The secondary storage is known as the auxiliary memory of the computer. The primary memory is temporary memory and the secondary memory is the permanent memory. The primary memory is costly, the secondary memory is cheaper. The primary memory has low capacity, the secondary memory has high capacity. The primary memory is volatile, that means it lost data without having power. The secondary storage is non-volatile, that means it retains data without even power. So these are the difference between the primary memory and secondary memory. When we will go for our fourth module, that is the memory of computer, there we will see the variants of the primary memory, the variants of the secondary memory. There are different types of memory we are having in our computer, but you just remember the memory for the uses we have divided into two categories, that is primary storage and the secondary storage. So the next functional unit is central processing unit. So in case of central processing unit, we have two parts, the control unit and the arithmetic logic unit. So let's see what is that arithmetic logic unit and the control unit. So the arithmetic logic unit of a computer system is the place where the actual execution of instruction takes place during processing operation. So what we have already discussed, that the data is the raw fact, the data and instructions is going to processed, and after the processing the data will be converted into some meaningful information. That means when we add some meaning, when we add some concept to the data will convert into information. So information is meaningful. So how we will add some meaning to the data? Who is responsible for that? Input unit is responsible for taking data. Output unit is responsible for giving information. Then how the data is converted into information? Who is responsible for that? The arithmetic logic unit is responsible for that. The actual execution, the actual processing is going to held by the arithmetic logic unit. There we are processing the data and instruction given by the input unit. Then the data and instruction will get processed. The data and instruction will get modified. The meaning will added to the data and instruction. Then it will convert into the information. And then we will get the information through the output unit. So the arithmetic logic unit is responsible for converting data and instruction to the information. So that is what actual execution. You just remember the arithmetic logic unit is responsible for actual execution. So what is that control unit? What is the work of control unit? So control unit is the nerve system of a computer. So in case of control unit, the control unit of a computer manages and coordinates the operation of all other components of the computer system. So what are the other components of the computer system? Those are your input unit, your output unit, your central processing unit, arithmetic logic unit, storage unit. So who is responsible for controlling these components? That is control unit. So that is the central nerve system. That will decide when the input unit is ready and when the input unit will take input. Is the storage unit is ready for storing something? Is the output unit is ready for giving output to the external environment? Is the arithmetic logic unit is ready to execute something? So there are lots of jobs. The arithmetic logic unit is responsible for executing those jobs. But we cannot execute all the jobs at a time. So who will decide which job is get executed first and which job is executed at last? That is control unit. Control unit manages all things. Control unit coordinates the functions of all other components. So that is the central nerve system. So by combining the ALU and CU, that means arithmetic logic unit and the control unit, what we will get? We will get the central processing unit. So the central processing unit is comprises of arithmetic logic unit and the control unit. The arithmetic logic unit is responsible for the actual execution. The control unit is responsible for managing and coordinating all other components like your input unit, your output unit, your storage unit and all. So by comprising the arithmetic logic unit ALU and control unit CU, we will have our central processing unit, which is the brain of a computer system. And the central processing unit is responsible for controlling the operation of all other units of a computer system. So what we have already discussed. So what is that system concept? So whenever we are concerned about our computer, we say that my system is not working. So what is that system? Why we call the computer as a system? What is the system concept? So actually a system is a well organized components. When two or more components will be well organized for performing some objectives or for performing some tasks, that is system. So we have three characteristics of a system. So the first characteristics of the system is a system has more than one element. So can we call a computer as a system? Yes, because the first characteristic says that a system has more than one element. So our computer has also more than one element. If you count, you can find 5 distinct elements: input unit, output unit, storage unit, central control unit and arithmetic logic unit. So we have 5 different elements. That means the computer is satisfying the first characteristics of the system. Next, what is the second characteristics of the system? The second characteristics of the system is all elements of a system are logically related. So what does that mean? Logical related. That means all components have some different work principle, but they are combined together for performing a single task. So all these components are logically related. We cannot complete that particular task without having one element. Suppose our motto of the computer is to take the data and instruction and giving the information. So suppose we remove the input unit. By removing the input unit from the computer, can we call the computer as a system? Or can we convert the data and instruction to the information? No. Because input unit is responsible for taking the data and instruction. Without having the data and instruction with us, how we are going to convert them? We don't have the data and instruction with us. So we need the input unit. So the role of the input unit is important. Like that, the role of the output unit is also important. The role of the central processing unit is also important. So all these components are logically related, what we have already seen in von Neumann architecture. The input unit is connected with the storage unit is connected with the output unit and the central processing unit. So all these components are logically related. That means our computer is also satisfying the second characteristics of the system, that is all components are logically related. So the third characteristics of the system is all elements of a system are controlled in a manner to achieve the system goal. Yes, our computer components are actually controlled by the control unit. The control unit will decide which job is executed first, which job will executed at last, how we are going to execute depending on the instruction. That means for achieving our goal, all of the components of our computer is controlled by the control unit. So our computer is satisfying all the three characteristics of a system. That's why we are calling the computer as a system. Or we can say a computer is a system as it comprises of integrated components. So what are those integrated components? Input unit, output unit, storage unit and the central processing unit. So inside the central processing unit we have the arithmetic logic unit and the control unit. So all these integrated components will work together to perform the steps. So what is that step? That is the executing a program. So these steps means the instructions. So what we have learned, the computer is a system because it has comprises of integrated components that work together to perform the instructions called for in the executing program. So whenever we are going to execute a program, we should call the instructions. So for that executing a program or for that execution of instruction, we have some integrated components in a computer those are logically related. So that's why we are calling the computer as a system. I hope you people are getting me. What I want to say you that you just consider the fundamentals of computer. In this 2 or 3 video lecture, we are discussing the fundamental or the basics of computer. In our forthcoming videos, we will go in detail into this. In our next class, we will go for the number system. Have a nice day and thank you.